Okay, so we're working on the predator-prey equations that we started in the last video, and I wanted to present a different method of analyzing the equilibrium, and that's by looking at something called the Nullclines. I think we may have talked about isoclines before. Nullclines in this case are curves where one of the derivatives is 0. Okay, and so because we have a system, right, we're not going to get both our curves where both things are 0 at the same time. And so, for example, in this case, we'd look for where x times 1 minus 1/2 y equals 0. And so that means we have two curves, right? X equals 0 and y equals 2. And then in the other equation, we have y times minus 3/4 plus 1/4 x equals 0. And so therefore we have y equals 0 and x equals 3. Okay. Now in the xy plane, x equals 0 would be this vertical line, right? So what's happening along that vertical line? Well, if x is equal to 0, then x prime is equal to 0, and y prime is equal to minus 3/4 y. And so if we're anywhere on this point, down here for example, then the x prime is equal to 0, meaning we're not moving to the left or right, we're only moving up or down. And if y is negative, that means we're moving up, right? And so if y is positive, we're moving down. Good. And so the only point that's frozen here is x equals 0. Okay, so similarly, we have this line y equals 2. So I'll just draw it in here somewhere. Y equals 2. Oops. Now along y equals 2, what's happening? X prime is equal to 0 again, right? And then y prime is equal to what? Well, if y is equal to 2, then we're just 2 times minus 3/4 plus 1/4 x, right? So this changes sign at x equals 3. So I'll just make a note of that. 1, 2, 3. Right? Oh, that's not to scale. 1, 2. Okay. So if x prime is equal to 0, that means you are not going left or right, you are only going up or down, right? And so if x is less than 3, what happens? For example, if x is 0, then y prime is negative, so you're going down. And if x is bigger than 3, right, for example, if x is 4, right, then y prime is positive, and you're going up. Good. And so at the point 2, 3, we're not going anywhere, right? Good. By the way, is this point right here, x equals 0 and y equals 2, is that an equilibrium? No, that's not an equilibrium, right? Because both points only take x prime to 0, they don't make y prime equal to 0. Good. Okay, so I've taken care of those two now. We can look at y equals 0 and x equals 3. So for y equals 0, we're down here at the origin. And if y equals 0, then what happens to x prime and y prime? Y prime is 0, so that means you're only moving left and right. And so x prime is equal to, let's see, y is equal to 0, so that's x prime equals x. And so if x is positive, x prime is positive, so you're moving away this way, right? Or on the, if x is negative, right, you're moving to the left. Good. And then finally, we have x equals 3, which is this vertical line. Good. And you should be able to, I'll leave it to you to see that if we're above the line y equals 2, we're going to be moving to the left, and over here we're going to be moving to the right. Good. And so you can kind of see already what's happening. We have two equilibrium solutions, one here and one here. And here it looks like something's happening that's interesting. Here this is what is this called? That's a saddle, right? So it looks like this is a saddle, and this is something, maybe a spiral? I don't know. So let's take a look at our Jacobian now. So now we have our two equilibrium solutions, 0, 0, and 3, 2. And now we can write down our Jacobian matrix, right? So that's going to be let me write it down here. 1 minus 1 half y minus 1 half x, 1/4 y, and minus 3/4 plus 1/4 x. Good. So what's going to happen at the origin? We have 1, 0, 0, minus 3/4. And so you can check that that is indeed a saddle, just like we were expecting there. But what happens at the point 3, 2? At the point 3, 2, I'll let you verify that. It is 0, negative 3 halves, 1 half, 0. And so in this case our trace is 0, and the determinant is 0 minus 3/4, so that's positive 3/4. And you could stop there, because where are you in the Poincare classification if trace is 0 and determinant is positive? You're right there. And so that is a center. So just in general, we have to beware when a linearization produces a center, because the real situation, it may be just a small perturbation of this solution. And so notice that if you move to the left or to the right, the center becomes a spiral, which is a completely different behavior, right? And so centers may or may not, we're estimating that it's a center through the linearization, but in the full nonlinear system it may not be a center. So you have to be careful with that. Our numerical simulations will tell us a little bit more. Okay? And so in fact, if we go to our numerical simulation, let's see what we get. Beautiful. We actually do get really nice centers. By the way, I cheated here. I used Runge-Kutta or RK4, and that's because if you just use Euler, clear the curves. Yeah, if you just use Euler, do you see what just happened? Our center became a spiral. Right? Center becomes a spiral. Oops. In that case, we're running out of space. Yeah, we're getting spirals instead of centers, and so we could crank this down, but it's probably just easier, right, to go to get a much more accurate method, the RK4. And now with a step size of 0.1, it's a beautiful curve. And so we have periodic solutions, right? And so unfortunately I can't draw just the x coordinate in time and the y coordinate in time, but we'll take a look at those I think next time. And so I'll be assigning things from 9.4. Well, I'll write down the solutions, or the homework problems. 9.4, 9.5 are competing species and predator-prey. We also took a look at some Nullclines today, so our book doesn't really use the method of Nullclines for very much, but I think it's useful, so I'm going to ask you to use the Nullclines on the competing species model. So just as a quick preview, let's take a quick look at that. So here was our predator-prey equations, right? So if we use the method of nullclines here, right, your nullclines are x equals 0 and y equals 1 minus x, or y equals 0, and then you have the, well, you can solve this equation, 3/4 y minus 1/2 x. 3/4 minus y minus 1/2 x equals 0. I guess I could solve that for y. There we go. Okay. And now remember what happens along these two curves. X prime is 0, and along these two curves y prime is 0. And so you can kind of see what happens. You know, if x prime is equal to 0, that means your direction of travel is only up or down for this one, and for this one y prime is 0. That means you can only move left or right. Okay, I've talked too much. I'm giving away the homework now. I'll set it up and talk to you later.